Evening, I'm Spot On Weather meteorologist Matthew Euler. Welcome to the latest winter forecast model outlooks. This is from the November issue of the various winter forecast models. So in tonight's video, what we're going to do is we're going to take a look at the latest model outputs. Kind of made a little funny picture here to start tonight's presentation off, showing a turkey. Of course, we're just a couple weeks out from Thanksgiving, and you'll notice snow on the ground. There's snow on the ground with this turkey. So we could be looking at a case of a cold turkey this particular Thanksgiving if the weather models definitely verify. But let's go right into the video. The overview of this presentation, I'm going to cover the CANSIPS winter forecast, the ECMWF CEAS5 winter forecast. Then we'll move into the NMME winter forecast, and then the C3S winter forecast. Additionally, after the forecast models, after we look at the latest updated models, we'll go ahead, I'm going to dive into a few other main points. So starting off with the CANSIPS model, I'm not going to read this verbatim, but generally I'll just leave this up here for you to take a look at. In general, it's run by the Canadian Centre for Climate Modeling and Analysis and the Canadian Meteorological Center. And it's a multi-model ensemble type system. It uses 2 climate models overall. And let's take a look at the CANSIPS 500 millibar height anomaly forecast. This was just recently issued on November 1st, showing yellow and orange colors indicating above normal heights or higher than normal heights based on climatology between 1991 and 2020. So anywhere you see the yellows and the orange colors, that's indicative of above normal heights. Whenever you see the blue coloring, that's indicative of below normal heights. And so generally, why is this important in the atmosphere? Whenever you have orange and yellow coloring, that's generally associated with more warmer temperatures as well as drier conditions. Wherever you see the blue shading, that's typically associated with increased storminess, more precipitation, and cooler temperatures. So let's take a look now at the breakdown of the meteorological winter months, starting with December here on the left from the CANSIPS. This is the 500 millibar height anomaly forecast, again, indicating those troughs and ridges. Whenever you see the gray coloring, that's just generally indicative of near average heights. So in general, in December, what we have going on is we have a nice little area around southern Hudson Bay into central Canada with above normal heights forecasted. We have below normal heights forecasted from the Bering Sea, western Aleutians, right on down into the Northeast Pacific. And another area below normal heights across North Texas and Oklahoma. But in general, for much of the United States, specifically the southern U.S., from California right on over to the Carolinas, the forecast from CANSIPS is for near average atmospheric upper level heights. Over here in the middle is the forecast for January. Now we see a little bit more deeper blue shades here off the west coast of the United States, associated with a forecast for deeper troughing and lower than normal heights, even greater lower than normal heights. We still see those above normal heights to the north over Canada, and then we have another area below normal heights across the Northwest Atlantic. And then finally on the right shows the forecast, the 500 millibar geopotential height forecast anomalies for February. Now, there are some changes for the Mid-Atlantic in February. We see a little bit more of this blue shading, indicative of more of a western North Atlantic storm track. Additionally, we see another area potentially with more in the way of a frequency of storms, generally going from the eastern Pacific, working its way through northern Baja. Higher than normal heights remain the theme according to the CANSIPS model at 500 millibar level. So we are looking at just higher than normal heights associated with warmer than normal conditions as well as drier than normal conditions. So again, here's just kind of my summary at the bottom. Generally, CANSIPS is signaling higher than normal heights to the north. Portions of the northern U.S. are also in this, by the way, for December, January, and February. And lower heights set up during the winter season, generally across near average to lower than normal heights in the blue shading across the U.S. A good chunk of the U.S. in January in the middle here and February on the right. Looking at the CANSIPS temperature anomaly forecast, very similar where the coloring is anyway. The orange coloring indicating above normal temperatures in degrees Celsius as compared to 1991 to 2020 climatology. So for December, we kind of see an extension of those slightly warmer than normal temperatures into the Mid-Atlantic up to New England. We see a even greater above normal anomaly in the temperature department across the Ohio Valley, upper Midwest. And then over here in the month of January, you'll note that we have above normal temperature anomalies, generally from upper Midwest up to central Canada. And then we have above normal temperatures, anomalies across Texas a little bit as well in January, according to CanSIPs. And then the far right here, look at this. The mid-Atlantic and the southeast coast below normal temperatures for February of 2024, and the blue shading here right up the eastern seaboard. And then again, warmer than normal temperatures across Canada and the northern US, which we typically see during an El Nino type winter. Now, when I look at these temperature anomalies, right, just because you see the yellow coloring or let's say the blue coloring, that does not necessarily mean that we're going to see a colder than normal or warmer than normal month the entire month. What we're looking at here is there's going to be many ups and downs in the temperatures during the winter months. These colors generally indicate the mean temperature, the average temperature overall. So you'll have a balance between some milder periods with some colder periods. The warmest temperatures, again, are going to be located across the northern US and Canada, according to CanSIP's model. As far as the CanSIP's precipitation anomaly forecast, green indicating wetter than normal conditions, brown drier than normal conditions. For the month of December here on the left, we see above average precipitation, this green shading extending from Virginia right on down to Florida, the Gulf Coast. And then also notice the entire East Coast is generally showing wetter than average conditions in the month of December. And then very similar in the month of January here in the middle of the forecast for precipitation anomalies showing above normal precip extending from Virginia right down to the Gulf Coast for Florida. We also see an area of above normal precipitation or wetter than normal conditions across much of the state of California, according to this model for January. And then finally over here on the right, this is the CanSIP's precip anomaly forecast for February 2024, showing again that same area from the Gulf Coast, Louisiana, the Carolinas, Georgia, up to Virginia, above normal precipitation. Florida is included in that. And so when I look at these precipitation anomalies forecast, I'm thinking to myself, this is indicative of a more energized subtropical jet stream, and more of a southern storm track is going to produce these type of precipitation anomalies. Now let's move on to the forecast from the ECMWF CS5 model. The nice thing about this model is it has coupling between not only the atmosphere and the ocean surface, but also the atmosphere and ice surfaces. So this is a nice little model. It's fairly recent, became operational in November 2017. Looking at the ECMWF CS5 500 millibar height anomaly forecast, the color schemes on these 500 millibar height anomaly maps are the same as from the CanSIPs. Oranges and yellows and brighter colors indicating above normal heights compared to climatology. This goes back to the 1993 to 2016 climatology database. The blue coloring indicating below normal heights or lower than normal heights at 500 millibars associated with increased storminess, storm systems and storminess. So overall, in the month of December, there's not really a whole lot going on here according to this model. We do see above normal heights, specifically the greatest above normal heights across New England into southeastern Canada. We do see this gray area here that's generally indicative of near normal heights. So we have an area from New Mexico extending east through Texas, Oklahoma, Arkansas, Louisiana, Mississippi, and Alabama with near normal heights. And then we also have an area of near normal heights across California. We turn our attention over here in the middle of the forecast from the ECMWF CS5 for 500 millibar height anomalies. Look at this bullseye of blue across the mid-Atlantic for January. And this is where we really feel like winter is going to get going. January here in the middle, this is an increased storm signal right here. And then also over here on the far right for February 2024, look at where the center of the storm signal is, the deepest hues of blue across the mid-Atlantic. So we feel that, maybe a milder start to the winter, meteorological winter in December, but it's going to turn in January and February. We look at the ECMWF CS5 temperature anomaly forecast now for the month of December over here on the left, showing a fairly mild picture across much of the United States with slightly above to more greatly above normal across Canada. January forecast for temperature anomalies here in the middle, showing a blue area now showing up from Louisiana, Arkansas, southern Missouri, southern Illinois, Kentucky, Tennessee right on into Mississippi, Alabama, Georgia, the Carolinas to the mid-Atlantic. Look at this blue area here for January's forecast. Below normal temperature anomalies showing up. And then over here on the far right is the forecast for temperature anomalies from the Seas 5. This is for February 2024, and look at the area that is blue again. So again, this is all matching up with the placement of the lower than normal heights, colder than normal temperatures are correlated with these lower than normal 500 millibar heights, troughiness clouds, increased precipitation, increased storminess in these areas here. Moving ahead now to the ECMWF Seas 5 precip anomaly forecast. Look at the green shading up and down the eastern seaboard for December. It may be dry in a lot of areas right now in the mid-Atlantic, but according to this forecast model, things are going to get wet, and they're going to get wet in a hurry. Once we hit the month of December, from the Gulf Coast working our way northeastward to the mid-Atlantic, Virginia, Pennsylvania, up to New England. By the time we get to January's forecast here in the middle, we do see that continued persistence of a wetter than normal signal, generally from Florida up to the mid-Atlantic. We have the brown shading now kind of creeping in into the Ohio Valley. Drier than normal conditions expected there. And then over here on the far right is the ECMWF Seas 5 precip anomaly forecast for February 2024, becoming wetter again. Generally the same areas from the Florida Panhandle, working our way through Georgia, the Carolinas, Virginia, up to New Jersey, Pennsylvania, into Massachusetts. So again, let me draw this out. I'm going to show you what the storm track would be just based on these precipitation anomaly forecasts. And it's pretty much the same amongst all the models, really. So if we do a storm track, we're probably looking at something like this. Okay, sorry, that arrow went kind of crazy on me there, didn't it? But in general, we expect more of a southern storm track, okay? For this case, in the middle here in January, we'd expect more of Gulf of Mexico cyclogenesis storm development, and then that moving right up the coast like this, okay, for January. And then February, a similar story. We see a lot of increased moisture right along the Gulf of Mexico, so we'd expect a storm track kind of go like that. So the areas along the eastern seaboard, right in this zone, okay, it doesn't matter what model we look at, and they're all showing the same type of wetter than normal signal, generally in all area, all models and all months. Now let's take a look at the NMME. This is the North American Multi-Model Ensemble. It is also a coupled model, and it's produced from the North American Modeling Centers. Here is the breakdown by month of the temperature anomaly forecast according to the NMME. Let me get my laser back out here. Okay. So for the month of December here on the left, showing very similar to the ECMWF Seas 5. The lighter yellow indicating maybe 0.5 to 1 degree Celsius above normal in this lighter yellow coloring, so not that great above normal. It's not like it's a drastic amount of warmth. Up here with the deeper oranges into Canada and stuff, now we're talking like 2 degrees Celsius type anomalies above normal, as well as down here 1.5 degrees C across the upper Midwest for December. By the time we get to January's temperature anomaly forecast from the NMME, we're now seeing white coloring here, just regular white coloring. And that's indicative of near normal temperatures for the month of January from Florida up to the mid-Atlantic. Another area of near normal conditions for temperatures is going to be California to Nevada, and generally milder than normal conditions across the upper Midwest, according to this model for January. And over here on the far right is the forecast, temperature anomaly forecast for February, showing near normal conditions up and down the eastern seaboard from Florida up to Maine. Okay, that's the latest forecast for this particular model. What this tells me is anywhere where you see this white coloring, that's going to be generally indicative of increased cloudiness and more precipitation as well. Because you got to realize when there's a lot of thick, low cloud cover in the wintertime, we have a low sun angle, we have limited daylight hours. That's generally going to, that thicker, low cloud cover is going to reflect a lot of the incoming solar radiation back to space. And so you're going to get cooler temperatures. Here's the NMME precip anomaly forecast. This is December here on the left. Oh, wow. Look at the same coloring here as the ECMWF Seas 5. Wetter than normal California for December. Wetter than normal for the southeastern U.S. up to the mid-Atlantic, extending northward up to Pennsylvania and New York State. The forecast here in the middle for NMME precip anomaly forecast. The wet signal continues for California for the month of January, according to this model, as well as from the northern Gulf Coast up to the mid-Atlantic. And then February 2024, the precip anomalies, they do taper a little bit further down south. If you notice December, let me draw this out. You notice December here, the forecast for NMME for the precip anomalies. Look how far north this above normal precip extends, okay, all the way up to New England in December. By the time we get to January, we notice the above normal line is kind of like right around the Delmarva area, extending southwestward across Florida and along the mid-Atlantic coast. And then when we get to February, this area is trimmed back even more, according to this model, for above normal precip. But regardless, it's in the same spots that we just looked at for the ECMWF CS5. And then finally, let's take a look at the C3S. This is a nice model here because it's a blend of many models. The European, you also have, let's see, let me get it up back here. Okay. So you have the European, the UK Met, the Meteo France model, the German Weather Service model, the DWD, the U.S. National Weather Service's NSEP, the Japanese Meteorological Agency, the JMA model, and the ECCC, the Canada's Environment and Climate Change model. Okay. Let's take a look to see what's going on with this C3S 500 millibar height anomaly forecast. Now, I broke these down by 3 months, all 3 winter months on the C3S data. And so in general, what we're looking at, this is for December, January, and February. The upper air pattern generally is consisting of above normal heights across the northern U.S. into Canada. Near normal heights is the white shading from Southern California across the southern U.S. to the mid-Atlantic. When we look at the C3S temperature anomaly forecast, you look at this white coloring here that's indicative of near normal temperatures, or probability of near normal temperatures, I should say. And here's where the highest probability of above normal temperatures is going to occur across eastern Canada, Hudson Bay. That's generally the area where you see above normal temperatures, increased probability, as well as Alaska into the Northwest Territories. Then finally, the C3S precip anomaly forecast, green coloring again indicating above normal precip, higher probability of above normal precip here. We are looking at probabilities here, okay? So again, the same area, okay? So we're having a lot of the same things going on between all these models. You noticing that? And then just to top it off, this is from Ben Knoll, who posts regularly on Twitter, or X as they call it now. Look at this, folks, okay? Again, super blend. Now, this is one of the most accurate forecast models. It takes into account both ECMWF plus UK Met. You kind of see it right up here at the top, upper left. And it's also signaling a very wet winter from the Gulf Coast right up the eastern seaboard. I mean, look at this. That is basically 100% agreement amongst all the models. They're locked down to a wetter than normal winter across the Gulf Coast, Southeast, Mid-Atlantic, for sure. Now, let's switch gears here after looking at those models, and I wanted to kind of break down some of the latest data here. First, the Nino 3.4 SST anomalies. Now this is the CDAS Nino 3.4 index, Oceanic Nino Index, ONI. Now, look what's going on here, okay? Initially, we had a little bit of warming. Now, so the past couple of weeks, we've seen what's known as westerly wind bursts move across the equatorial Pacific area, right? And usually what the result of these westerly wind bursts is it causes a warming trend in the sea surface temperature anomalies, causes the waters to warm. So you look at this area, we had a little bit of a spike from around October 20, 21st, right on to about Halloween. And now look, it cooled off again in early November, and now it's kind of remaining steady. But 1.26 degrees C above normal, this is what we're looking at right now. For CDAS Nino 3.4 index, it showed warming initially after during the westerly wind burst, and now it's kind of cooling off again. We look at Nino 1+2 SST anomalies. This is going to be located right along the west coast of South America, furthest east. Okay, so can we all agree on one thing here? Okay, can we all agree on one thing? Look at where this Nino index was in 1+2. It was well above 3 degrees Celsius. Look at this, okay? Back in late August. And everybody's like saying it's going to be a super Nino. Look out. It's going to be like 2015, right? But now look at the step downs we're seeing. Step down, step down, step down, step down, step down. A slight recovery here, and now we're on a step down again, okay? So right now, look how much it's cooled from just around 3C above normal water to now just 1.65 C. So this area has cooled overall since 30 August, the Nino 1+2 region. What about the Nino 4 region? Now this one is the furthest west region, okay? This is closer to the international dateline, 180 degrees west longitude. pretty steady. The steady state from August right up to mid-October. We had a little bit of a spike here in mid-October, then a drop off, then it goes up and warms a little bit. Now we're kind of flatlining it right in here. But overall, we're looking at a plus 1.01 degrees C anomaly in that Nino 4 region. So steady to slight warming trend generally in the water temps in Nino 4. Now, this is not the only story though. The water temperatures, what they're doing. We need to look at the overlying atmosphere and how it's coupling. We do this through something that's known as the MEI, okay? And this is the latest forecast now. So the gray line, let me show you here. This gray line here is generally indicative of the MEI value, okay? And you'll notice there was a rise from June and July, September, October, December, January, March, April, June, July of this past summer in 2023, and now there's a drop. Now look at all these other color lines. They represent the MEI values in various El Nino years. Look where we are now, okay? Look at where we are right now. I'm going to circle it, right? We're here now. We're down here, okay? We're well below all these other Nino years. The other Nino years, 83, 87, 92, 98, 2016, are well above the value of MEI where we are right now. So what's this mean? This means that the atmosphere is not completely coupling with the warmer sea surface temperatures associated with El Nino. So why does that matter? Because if the atmosphere is not responding the way it should, in accordance with how strong the warming is with El Nino, the overall pressure patterns are going to not match up ideally with your typical El Nino year. That's why it's important. How the subtropical jet stream sets up, where the synoptic pressure feature set up. MEI value is not up to par with any, not even close to any of the stronger El Ninos up here at the top. So this is really interesting stuff. This is the latest update. I could not believe that it actually dropped lower than last month. Another consideration, this is the NMME SST anomalies, okay? This is the forecast. This is the forecast. On the left here, I have December, January, and February for sea surface temperature anomalies. Brown shading is indicative of very warm. This is the warmest sea surface temperature anomalies, brown. The general oranges and the maroons indicate above normal water temperatures, okay? This is December, January, and February on the left. Now look where this brown area is along the equator there in the central, eastern and central equatorial Pacific. Okay, look how far west it extends, all right? It's not in Nino 1+2, the warmest sea surface temperature anomalies, right off the west coast of South America. It's not in Nino 4 technically near the date line here. It's in between. And then here's the forecast on the right for the sea surface temperature anomalies from the NMME, the forecast for January, February, and March. Look at where it is. The brown coloring indicates the warmest sea surface temperature anomalies. It's not here off the west coast of South America in Nino 1+2, and it's not here in Nino 4 region. It's in between. So what does this mean? This is another wild card we have to consider for the upcoming winter circulation patterns across the northern hemisphere. To me, this indicates a hybrid El Nino this winter between those two regions, Nino 1+2 and Nino 4. And so I'm not forecasting an east or central based El Nino, but kind of the in-between area. And I've noticed this brown coloring has shifted slightly westward over the last month's model guidance. But in general, we can expect to have the warmest sea surface temperature anomalies, not completely east-based, not completely central-based, but kind of in between. Here is the El Nino Walker circulation. I'm going to kind of tie things in towards the MJO here in a moment. But in general, during El Nino conditions with Walker circulation, you generally have sinking air motion over the western Atlantic Caribbean. You have rising air motion around the international date line. That's associated with the MJO phase 8. You have sinking vertical air motion over the maritime continent, Indonesia. That's associated with the warmer MJO phases 4 and 5. And then you have rising air motion again around Africa there, East Africa, associated with MJO phase 1. So we really need to take a hard look at this. We really need to take a hard look at this data and figure out where the air is rising, because that promotes clouds and precipitation and tropical convection. And so we have rising air generally in the vicinity of Africa and in the central equatorial Pacific, and that's going to be associated with these colder MJO phases, phase 1 and phase 8. And I'll show you what's going on here in a minute. Now, sinking air motion is associated with clear skies, dry weather, below normal precip, in association with the MJO phases 4 and 5. Now, let's look at the MJO forecast in general. Jeff's V12, this is all the latest forecast data as of the 13th of November, 2023. Now, anytime you're in phases 8, 1, and 2 on this side, this is the colder side of the MJO phase diagram, the left side. Okay, so I labeled colder side on all three of these forecast plots. Warmer side is going to be over here in 4, 5, and 6, over in this area here, in each of these plots. MJO phases 4, 5, and 6. All right. Okay, so all models right now follow the red line here. Jeff's V12 is on the left. All right, CFS V2 extended is here in the center. Look at that red line. And the ECMWF, the latest forecast for today for the Madden-Julian Oscillation Forecast, MJO, red line. All of them are in agreement with the MJO moving towards phase 8 and then phase 1. Now, those are the colder sides of the MJO phase diagram. Colder sides for the Mid-Atlantic. Colder sides in general for the eastern U.S. Whenever the MJO is out in this area, 8, 1, and 2 phases. Convection in the Western Hemisphere and Africa, okay? You get milder conditions and milder temperatures when the convection, the rising air motion, is in over the maritime continent, 4, 5, and phase 6. But look at, none of the plots are showing any kind of MJO rotation on into the warmer area of the diagram, the warmer side of the diagram. So all models are generally in great agreement for the MJO to move into phase 8 and then phase 1, the colder side, in late November. And this makes a lot of sense based on what we have going on right now. We have a positive Indian Ocean dipole, positive IOD, and we have the El Nino. And that's going to, I kind of showed you El Nino here, how the air rises and sinks in various areas associated with MJO phases. Now, let's take a look. Let's take a look at some more things here. I'm going to go into, let's see, I don't have I'm surprised I don't have IOD right there, but maybe, okay. Thought I had the IOD in here, but maybe I don't tonight. Anyway, the bottom line is the forecast is all the models are in good agreement for phases 8 and 1. Okay, this is not changing. Look at where it's been. For over a month, it's been in the same area, and it makes sense based on El Nino. It also makes sense based on the positive IOD, which I can't believe I don't have that for you. Let me see here. Hang on a minute here. I won't worry about those. Okay. I thought I had it. Oh, yeah, I do have it. I just have it hidden. Okay. Let me show you this. All right. For the Indian Ocean dipole, look at where the air rises. Look where the air sinks by these blue arrows. So we have sinking air in the Indonesia, maritime continent area. Those are associated with the milder MJO phases. So air is not rising in those warmer MJO phases. The MJO is not going to be favored in this area in phases 4 or 5. MJO will be favored according to the IOD, positive IOD circulation east of Africa in phase 1, where we have the warmer than normal water temperatures in the Western Indian Ocean. Look at the forecast here on the right. I gotta get my laser pointer back. We see we pretty much are hitting a peak right now in November of IOD, almost up to 2 degrees Celsius above normal waters across the Western Indian Ocean. But then it's eventually going to drop off. See how it's starting to drop down in January and February. But overall, bottom line is this is promoting, again, we are showing you a very positive situation for colder phases of the MJO, okay? See, there's El Nino, and for MJO, we're expecting it to remain over here in phases 8-1, generally most of the winter season. Now, during El Nino, specifically strong El Ninos, MJOs, according to research, tend to not be that strong. So that's another factor here. Although we're saying the MJO may remain over this area in the colder side of the phase diagram, doesn't necessarily mean it's going to be strong. So we'll have to keep an eye on that. Why is phase 8-1 so important for the months of December, January, and February? Look at this. Blue coloring for phase 8 across the east. Phase 1 also showing blue coloring from the northern plains to the east coast. Phase 2, also colder look for the East Coast. Again, 4, 5, and 6, the orange coloring here indicating above normal temperatures. And we do not see this going to 4, 5, and 6, the warmer side of the MJO phase diagram anytime soon. And we're not really anticipating it this winter. All right. Here are the different phases of the MJO, by the way, on the right, from phases 1 all the way to phase 8. Wherever you see the number, whenever there's rising vertical air motion and increased convection and precipitation, that will correlate with the various phases here, the various geographic locations. Phase 8 and phase 1 are the big ones for a colder eastern winter. Here's some additional information from the C3S. I wanted to point out where that air is forecasted to rise for December, January, and February. Associated with phase 1 here, east of Africa. See the darker green coloring here? All right, so this is, the C3S is showing this. It's showing above normal precip, which would be associated with rising vertical air motion, MJO phase 1. We look at the European C5 precip anomaly forecast from early November. We have that rising air motion here in the far right. I got a circle around it, same area, east of Africa, associated with MJO phase 1. And then we also have some rising air motion around the vicinity of the international dateline associated with MJO phase 8. And then the NMME precip anomaly forecast, the global precip outlook. Same song and dance here, everybody. Generally increased above normal rainfall across areas east of Africa associated with MJO phase 1, upward vertical motion here. We got downward sinking air motion where the brown coloring is. See this brown coloring? And then we have upward vertical motion again near the international dateline. So this is the favorable MJO phase. You kind of see our above normal green coloring here from the Gulf Coast up the eastern seaboard for December, January, February. But in general, really wanted to point out these circular areas as key points. So here are my takeaways from tonight's video. From everything we just gleaned over, temperatures are going, basically according to the models, are going to be slightly above normal in December, with greater probability for near normal to slightly below normal temps into January and February across the southeast and the mid-Atlantic. This is a medium confidence still. There's a lot of variables that impact winter temperatures at the surface. We haven't even talked about the stratospheric polar vortex, which I do mention in my teleconnections discussions, but that's for another day. So there's a lot of variables, teleconnections working with each other or against each other. Destructive interference, constructive interference, I talk about it a lot. So I would go with a medium confidence at this point still, as far as the temperature regimes. For example, we're forecasting temps slightly above normal in December, but, that doesn't mean we couldn't get a couple really good cold shots in here in the east. Long-range models are also an excellent agreement indicating what are the normal conditions for December, January, and February for the southern U.S. to mid-Atlantic. Very high confidence. Every single model I showed you tonight from the November update shows this. Above normal precip from the Gulf Coast up the eastern seaboard. It specifically from the southeastern U.S. to the mid-Atlantic. This is just not changed, and I've been watching these models for the last 3 to 4 months, and they remain lock in step. The tropical forcing, that convection, the areas of upward vertical motion, those are going to be focused east of Africa and near the dateline. And again, that's going to favor the same MJO phases, 1 and 8. Really no changes from last month. MJO remains persistently on the 8 and 1 colder side of the diagram. I already talked about this pretty extensively. We're over here where these lines are right here. Okay. Moving on now, higher than normal heights at 500 millibars are forecast for Canada and northern U.S. That will promote milder and drier type conditions, near average to below average heights across the southern U.S. And of course, this is going to change across the southern U.S. dependent on upper trough placement with transiting storm systems as they move from west to east. Looking at the warmest sea surface temperature anomalies, again, shifting westward. They're shifting westward from last month's NMME model run, indicative of that hybrid El Nino situation. Let me go back right here. Yeah. You see where the brown coloring is in both of these. December, January, February, and January, February, March. Okay. And then no matter how you slice it, okay, the atmosphere is not fully coupling or responding to the underlying warm sea surface temperature anomalies in the equatorial, eastern, and central Pacific. It's just not, as far as this MEI value. And this has big implications on the overall weather pattern during the winter season, how things set up, the storm tracks, where the ridge is set up, where the trough set up is all connected. got to realize that, the atmosphere starts at the ocean surface and works its way up into the air, overlying air mass. So it's not like you can just put a line between the ocean surface and the overlying air, the atmosphere, and say they're two separate pieces, because they're not. They're connected. And what happens in one piece impacts what happens in the other piece. Additionally, we are seeing a potentially progressive nature to the upper air pattern in December. That would be more in the way of, fastly moving troughs and ridges across the U.S., yielding to a more cold, stormy pattern for the mid-Atlantic in January and February. So again, all signs are pointing that way. I personally, out of all these models, I've watched some of the performances of these models. This super blend is absolutely really accurate. And then the other one I really go with and like to go with is this ECMWF Seas 5. I think these two models are like the best models out of all these as far as performance. Again, that's just my opinion from what I've observed over time. All right, that wraps the video up, the presentation this evening. I hope you enjoyed the presentation. Hope you're enjoying your time, your evening, and thank you so much for subscribing to the Spot on Weather YouTube channel. Again, thank you so much, and until next time, I got a lot more coming up. Until next time, everybody, take care and God bless everyone.